On to this video, we are going to look at polynomial tutorial sheet number 1, and we are going to look at a few number of questions here. I've just picked some questions that might pose a challenge to you guys. So the first question is where we are going to solve the following. All right, so we are providing solutions to the following questions. So find the values of x that satisfy the following inequalities. Okay, so let's solve the first one. Okay, so the first one is 3x squared minus 4 is less than 4x, like that. Okay, so what we do is that we put everything one side. All right, this will transform this into 3x squared minus 4x minus 4 less than 0. We are going to factorize this one, so we find the sum and the product. So the sum is the number in the middle, negative 4. The product is the number in front multiplied by the constant, negative 12. Factors, negative 6 and 2. Try to multiply these, you get negative 12. Try to add, you get negative 4. So we're going to transform this one now into a factorizable inequality. So this one will be 3x squared. We can say plus 2x minus 6x, then minus 4 less than 0. So this, when you group this here, we get x as out, then you put 3x there, plus 2. We can see that the negative 2 is common here, so remains what? 3x plus 2 less than 0. So now we can group what is out there. So x minus 2 and 3x plus 2 is less than 0. The mistake that you're going to make is to just say this equal to 0, then you start solving. No. Here we are finding the value of x that satisfies this. The fact that there's less than, not every value of x here will be needed. So how do we do that? We are going to use a table to test. So how does the table work? So we are going to have 3 options. So do this. Equate this to 0 first. Okay? So these are the solutions, right? So say x minus 2 is equal to 0. So we are getting x is equal to 2. You keep this one. You say 3x plus 2, you say equal to 0. So x is what? Negative what? 2 over 3. You keep this one. These are the ones that we're going to use to test our table. So how will our table look? Our table look like this. So because this is a negative, so we are going to have a situation where we're looking for a number x which is less than negative 2 over 3. Are we there, right? We're also going to look for a number which is between. We're also going to look for a number which is between this and 2. So this x, a number between this and that. Then the other one to be a number x which is greater than what? 2. Then we do that. All right. Then what are we going to put here? So I can do like that. So here we are going to put our parts. All right. X minus 2 and 3x plus 2. These are critical values. All right. These are the critical parts. So you can put critical values here. So now a number less than negative 2 over 3, we can get negative 1 because negative 1 is less than this. So if I put negative 1 here, I'm getting the answer as negative. I'll get negative 3. I'm getting negative 3. So the answer, I'm just interested in the sign, right? Then if I put it here, then here we say x minus 2 multiplied by 3x plus 2. Like that. If I put negative 1 here, what am I getting? My answer is still negative 2, so I'm still getting a negative. But from the word go here, these two are multiplying, right? So negative times negative, you get positive. All right. If we get a number between negative 2 over 3 and 2, we can even get 1. If I put 1 here, I'm getting negative. If I put 1 here, I'm getting positive 5. So positive. Negative times positive is negative. Good. If I get a number above 2, if I put, let's say 2, if I put 3 here, this will give me positive. If I put 3 here, I'm getting positive. I multiply them, I'm still getting positive. But where does our solution lie? This is a very important part. Look, we are dealing with what? Less than. If we are dealing with less than, we go where we have a negative part. What do we say? We say now that our answer, lies between negative 2 over 3 less than x less than what? 2. That's a solution between that. Are we there? Let's look at another one. The next one is this one. Mistake number 1, you cross multiply. We don't do that in here. Just take this one this side so that you can have 2x minus 1. You divide by x. So you get negative 1, then we equal to 0. Then you can work out this fraction. Common denominator here is x plus 2. Divide this one into here, we get 2x minus 1. Here into here we have minus, then x plus 2. Like that. Which will give us what? 2x minus 1 minus x minus 2 over x plus 2. Then we equal to 0. And our final catch will result into, there we're just getting x minus 3 over x plus 2 less than or equal to 0. We've transformed into this state. We don't even have to solve anything here because we're just going to use our critical values. We test. As usual, get our table. So remember what we are doing before we test. We are equating these guys to 0. So we are saying x minus 3, you say equal to 0. So our answer here is what? 3. So we keep this one. Our next is x plus 2, you say equal to 0. And here x is equal to negative 2. Negative 2 there. So you keep this one. We come now to test. The negative number will start. So we're looking for a number x. We're looking for a number x such that it is less than negative 2. We're also looking for a number x such that it is between 3 and what? Negative 2. We're also looking for a number x such that it is greater than what? 3. Then our critical values are x minus 3. Our critical points like that. Then they are dividing, so we say x minus 3 over x plus 2 like that. So we do that, we do that, we do that, we do that. Are we together? We can now start testing. Get a number which is less than negative 2, negative 3. So if you put negative 3, you're getting negative. If you put negative 3 here, you're still getting negative. Now they are dividing, right? So what is negative divided by negative? You get positive. So you're getting positive there. A number between negative 2 and 3. There are a lot of numbers. There's negative 1, there is 1, there is 2. So get in. Okay, let's get 2. If I put 2 here, I'm getting negative. Correct? If I put 2 here, I'm getting positive. Positive divided by negative, you're getting negative. A number greater than 3. Let's get 4. If I put 4 here, I'm getting positive. If I put 4 here, I'm getting positive. If I divide them, I'm getting positive. Check. It's time to check. Are we dealing with less than or greater than? We're doing greater than. We are doing with what? Greater than. Is it making sense? I hope we are moving together. Is it making sense? Alright, so we're doing positive. Since it's greater than, that means we're looking for the positive one. So our answer lies there. So our answer lies here and lies there. So, final answer check. Final answer. We have x less than negative 2 and x greater than what? 3. But check, the sign we are using is what? Is greater than or like that. This. So yeah, we include it there and there. Are we going to leave it like this? We are big people. We can use certain notation. This is why you learn to say it. So we can represent this one as x is a member of what? Since this one is less than, so it will be negative infinity all the way to what? To 2. Right? Like that. Now, let's check here. Let's check before we even go anywhere. Is negative 2 included in this case? Is negative 2 included? We can check it out. If I put negative 2 here, alright, if I put negative 2 here, well, I'll be having negative 5, correct? If I put negative 2 here, this will give me 0. And the 0 divided by, a negative, that will just be a 0. So negative 2 is not included. So we remove this friend of ours. It's not included. So we do like that. Union, is 3 included? We can check if 3 included. If I put 3 here, I'll get 0. This will be positive, also 0. So, do we include it? Or do we just, leave it? So, you discover that, in fact, let's do this. Like that. Then, we are moving all the way from 3 all the way to positive infinity. But here we do that. At least now it's fine, eh? Coming to think about it, I think this should not be included. And I'm going to explain why. From the word go, our inequality was greater than what? 1. It was greater than 1. So something less than negative 2 should not be there, but something greater than negative 3 should be included. Yes. Another one. The last question is this one here. It's a modulus type of function and it's less than or equal to 3. Before you even go anywhere, we need to transform this one. We know that the modulus of a function x is equal to x or negative x, depending on the conditions, isn't it? And we are going to transform this one in the same way. All right, so this can be transformed in, so this is the same thing as x minus 4 over x, let's go, less than or equal to 3, and so it will be between these. Transform this one into 2 parts. That means we have the first part and we also have the second part. So let's start with the first part. The first part is negative 3 is less than or equal to x minus 4 over x, which we can write this as x minus 4 over x. Since it's less than, if we flip it the other side, it becomes greater than or equal to negative 3. If you flip it, if this one comes this side, right, it's fine. Of which we can now write as x minus 4 over x plus 3 greater than or equal to 0. Working out this fraction, okay, should give you x there as a common denominator, and there is x minus 4, then there's 3x, so we are getting 4x minus 4. Confirm with me, because you'll be getting this. Then is greater than or equal to 0, of which we can factorize here. We say 4x minus that, x minus 1 over x greater than or equal to 0. Well. Do you think we can do away with the 4? We can divide it throughout such that we get our final answer as x minus 1 over x greater than or equal to 0. So this is what we are getting from the first inequality. Let's go to the second inequality. The second inequality is x minus 4 over x less than or equal to 3. We take this one the other side. This becomes x minus 4 over x minus 3 less than or equal to 0. We do the same like the previous one. And you can also confirm with me that this will give us x minus 4. The common denominator, of course, is x. But we're getting x minus 4 minus 3x. Yes, which will give us negative 2x minus 4, which we can less than or equal to 0, which you can also factorize here and say negative 2 is common. So we remain with that plus 2 over x less than or equal to 0. Correct, right? And the final answer will just be x plus 2 over x. The negative 2 can go out, so we have this like that. We're moving together. So now we work out each problem separately. We work out each problem separately. How do we do that? Well, the same way we have been doing. So this is a part where we have x minus 1 over x. So x minus 1 over x greater than or equal to 0. We solve it separately. We also solve this one separately. X plus 2 over x, is it less than or equal to 0, also save it separate. Then remember that this is just an intersection part. So where they're intersecting, that will be the answer. So can we do this one? So we know that the first one here, we know that x is equal to 1 and x is equal to 0. Clear, right? And here we know that x is equal to -2, right? And x is equal to 0. Now let's solve. So we are going to put our x minus 1 here, then we're going to put x there. Here the same thing will follow. We're going to put x here. Here we're going to put x plus 2, then we're going to put what? X. That's like that. Then we're going to put a number, of course, x less than what? 0. We're going to put a number between that, and also going to put a number x greater than what? 1. Supposed to be 1 there. So 1. We come here, okay? So I'll do that. We come here, we do the same. We are going to put a number which is less than 2 now, -2, or a number between that one, or a number which is greater than what? 0. So we can now do that and do that. Do that. We can branch them. We can branch them. So a number less than 0, we get negative. For example, -1, we get negative there. If I put -1 here, just -1. But remember that they are dividing. These two are dividing. So let me just say solution. These two are dividing. So negative by negative, we get positive. Good. Even here, just put solution. If I put a number between 0 and 1, a number between 0 and 1 can be any number. Even 0.5, it's fine. Put 0.5 here. The answer you are getting is actually negative. If you put 0.5 here, it's just positive. So it's discovered that you are getting negative there. A number greater than 1, you get 2, for example, you get positive there, and positive here, so you're getting positive there. We come here, we do the same. A number less than -2, we can get -3. If I put here, I'm getting negative. I put there as negative. Solution, positive, right? A number between -2 and 0, I can get even -1. If I put -1 here, I'm getting positive. -1 there to be negative. I divide, I get negative. A number greater than 0, I can get 1 there. 1 will give me positive, and positive, which will be positive. So we can clearly see that our answer is here, because we are dealing with greater than. Here it is greater than. Here it is what? Greater than. But here it is less than. Here. So here our answer lies there, but here our answer lies there. So is there any intersection here happening? Alright, so from the first one, we understand that our x is actually starting from all the way from less than 0, right? Which is -infinity, all the way to 0. And of course, we close it like that. Union, 1 is included, all the way to positive what? Infinity. When we come here, our x, is just between, okay, it's fine. We can also get the positive. I don't want to, well, what can I say? I don't want to be that biased, because from the word go where? Our function was less than. But we transformed it into two parts, the less than part and the greater than part. So let's start here. Our answer is actually between this and the 0, like that, which we can just say x is a member of -2, 0, like that. Now, look at what we have here and what we have here. Is there any intersection? When you look at it, you can even use the set lines to draw this and show that they're actually intersecting somewhere. But there's something which is actually very interesting here. Here we are running all the way from -infinity to 0. And this one is from -2 to 0. We can clearly see that our lowest here is -2. Alright? All the way to 0, union. Our greatest is actually 1 to infinity. 1 to infinity, and 1 is inclusive, like that. You might wonder, how come? Take note, 0 is already there. So ndiye hapa, so the negative 2 is there. That's where it's ending. Then we come. This part is not being tempered because there is nothing here. So this becomes our solution. And thank you so much. Please revise these questions. They may seem a little bit tricky, but go through is to the previous, and I'll be able to see you in another tutorial.